Mathematics is often perceived as a very abstract discipline, and uh, but however, it is a bedrock of all the things happening around us. And I want to focus on this other aspect and kind of try to destroy the myth that maths is only abstract. Okay, uh, some of you would have at least heard something like, and certainly mathematicians, pure mathematicians, would not only have heard, they might have even used this line, quoting G.H. Hardy is supposed to have said that I am happy that my work, I started with he was happy, but then I changed, okay. So I am happy that my work is not useful for any real applications. He's supposed to have said something like this. Now, earlier I would give this quote and try to interpret my own as to perhaps when, why, etc., etc. And yesterday, while I was preparing this, I said, why not ask ChatGPT? So that's what I did actually. Okay, did Hardy really say this? And it said that he did say something like this. And the answer is, it is his famous essay, A Mathematician's Apology, 1940. Hardy wrote that he took pride in doing useless and pure maths, which he contrasted with mathematics that had practical or military applications. Okay. And here is the exact extract from this. Okay. I don't want to read it, but I will be also sharing the thing later with here, and you can yourself do ChatGPT and get exact quote also. Basically saying that he doesn't like to do things which have applications. Now, as a youngster, I used to always wonder that, I am not doing something deliberately with the aim of having an application is one thing, but why would I like if what I do has no application? I always used to wonder. And I had my own theories which were proven to be correct, because I'll tell you there. Okay. Then here is the other thing, that is a melancholy experience for a professional mathematician to find himself writing about mathematics. The function of a mathematician, almost like what you were saying, that, isn't this what a mathematician should be doing? To prove new theorems, to add to mathematics, not to talk about why or how it will be useful, etc., etc. So this is also there, but what is missed is a line, the last thing here, a line before that big quote was there in his book. It says, no one has yet discovered any warlike purpose. So the year 1940 and this phrase, warlike purpose, these two explain why he was so thinking about it. 1940, book published 1940, so probably this is written before World War II began, which had few months before that. And World War I had already happened, and he had seen the impact of maths in the warfare, and disgusted with that is what drove him to write this. Okay, so it has to be in that context. It makes sense. Okay, but not necessarily in general. But a whole lot of generations of mathematicians have quoted just that statement and be happy with themselves that we won't do anything applied. Okay, all right. So the fact of the matter is, and one can do a whole lot of, especially now sitting at home, one can do all kinds of searches and figure out what happened when and all that. That whole lot of mathematics actually got developed because of a particular specific need for something. Okay. Then somebody did generalize. Sometimes the generalizations are also useful, sometimes not useful. But and there are cases we can cite where something was developed purely out of interest and nothing ever was useful. But they are rare, rather than the rule. Okay, that's the exception rather than the rule. So now, early examples of use of mathematical ideas is astronomy, not astrology. I am talking astronomy. Okay, so now. Let's see, why were people interested in movement of stars, right? So it can be that, okay, some of them just out of they are interested in anything, and then they see stars moving and figure out why they are moving the way they are, how can we explain, blah, blah, blah. But more than that, it is to do with that, connected it with agriculture and weather. The movement of stars is connected with weather, which in turn, if you can have a good understanding of the weather, you would do agriculture better. So whether you call it application or not is up to you, but the purpose is very clear that if you can figure out how the planets move, you can figure out how the weather may behave, not exactly, but roughly, and that will help you. And this is what I can call very early beginning of what today is being called data science. You observe things around you, you locate them, relate them to things of interest to you, and figure out a relation, not exact, but approximate. And you make a gain out of that, right? So, one can come up with tons of examples of this. So, interesting is cryptography. Cryptography had its beginnings perhaps in communications between kings and their generals. You can go back thousands of years back, and there were kings, and every king wanted a large empire. And large empire means you need generals who will go far away and try to keep conquering more and more areas. How do you control these generals? You need to communicate to them. How do you communicate to them? So what is now being called authenticated secure communication was a need for just the king to communicate to the generals. And while I'm sure thousands of years ago people would have figured out a way, but those were days there were no way of writing down. In India there was only oral transmission. There was no written stuff. So we don't really know what the kings in India did. Okay, even in the West we don't have, but at least the Caesar's time, so like about 2000 years ago, there is a recorded history as to how Caesar had figured out, or Caesar's advisors had figured out how to communicate, and that is what is called Caesar cipher. Okay, and if you just look at this one sentence written here, it makes no sense. Gibberish it looks like. Okay, and the thing is, if you somehow get to know that what kind of algorithm or rule Caesar was using, then it's trivial. The rule was you write 26 characters and you just rotate them by some fixed number. Now you have only 26 combinations available, and if you know the rule, you can figure out what the thing was. And this is the message. Okay, so as long as nobody knew what that he's using, he or his team is using something like this, that was secure. You can't make the head or tail out of the previous sentence. But this apparently was used for years, till it became well known, and then Caesar knew that everybody knows it, so now it is useless. Okay, so so in a sense, it's mathematics. You may say it's a trivial mathematics, but it's a mathematics which ruled for 100 years maybe. Very simple. A kid can do it, but he has to be told what to do. Only then the kid will know it, right? So of course, it's like a lock. You use a lock, then somebody breaks it, you figure out, oh, for its purpose this is not good enough. You make a better lock, and then you make an even better lock, and so on. So this is a cat and mouse game, and it went on for years, cryptography and improving the algorithm or improving the way you would do it, and vice versa. Okay. So there is something called general substitution cipher. So over the years, various kings improved the Caesar cipher, tried this rule, do this, do that. Instead of 26 characters, you also add this, you add that, making it more complicated. You can add dot and you can add dash and do various such things. And there is a oldest recorded thing that can be traced is a book written by Al-Kindi around 800 AD. And the title, it's in Farsi, but it is translated is On Deciphering Cryptographic Messages. Okay? And it contains the first description of what is called cryptanalysis and frequency analysis. Okay, so breaking codes is called cryptanalysis. Cryptography is the overall science, and crypto algorithm and cryptanalysis is breaking codes. And breaking means, like in the Caesar cipher, this kind of information that it is generally rotating algorithm, rotating and then doing, but only what you do not know is by what degree you are rotating. Okay, so that kind of, if anything is being used on a large scale, roughly the rule can be known to a large number of people. Very difficult to protect that. So the entire focus then is on the key or password. Okay. So that is, and trying to bypass that, and instead of trying brute force of trying all possible passwords, which was easy in the Caesar case, if your number of things you have to try becomes large, it may be difficult to do brute force. And you try to figure out some pattern, and that is what is called cryptanalysis. Okay, and interestingly, it's the book, the method described by him in depth there in his book is, it's frequency analysis means you, in English language, for example, the thing starts with the character E. The letter E is the most frequently occurring. You take any large textbook in text, not specifically written to fool this algorithm, okay, and you count the number of times A, number of times B occurs, C occurs, E is always the largest, and then there is of course the vowels come almost at the top, and then the others, and so on and so forth. Okay, and once in a few years I do teach such a course in CMI, and it's open to BSc first year to MSc final year students. And when I tell this, that the general substitution cipher means you take you have to A to Z, okay, you permute them in whichever way you want. So 26 factorial permutation. So brute force attack is almost impossible. 26 factorial is a huge number. Okay, so you fix a permutation, don't show it to anybody. Then I would tell them, go to Project Gutenberg and take a large text written by Shakespeare or any other. The whole lot of books are available. Main thing is, you don't write a text to fool the algorithm. You take a text which already is there, do this transformation, okay, and give it to me. Each one gives me, then I share. So you get somebody, but you don't know whose it is. And I tell them that just use frequency analysis to break and see whether you can do it. So initially they said, but why will it break, sir? How can we do it? There's very little information available. I said, okay, we'll debate later. You first try and do it. So some of them would do it in half an hour. Some may take 1 day to do it. But everybody could break the code. Just this using the simple frequency analysis. That is how powerful it is. This is perhaps the first book in what later is being called statistics or data science and whatever, or cryptoanalysis. So the point is, can I say that no such thing were available in India? No, I am not asserting that. It's just that we did not have a tradition of writing it down. Doesn't mean Indians didn't know and only others knew. There's a difference. So it's even saying that Indians didn't know is as bad as saying that we knew everything. Both are incorrect statements, right? All right. So, but this is what this frequency analysis. Of course, it was not for English language. It was for Farsi, and the large text available at that time. Of course, the Gutenberg project and internet was not available. So that was Quran. So the analysis done is the frequencies of characters appearing in Farsi in Quran. And that was used as a basis to explain his method. So very interesting. And is there in some books somewhere description, but very in minimal. I didn't know. I am supposed to have done work with cryptography for years. I didn't know. It's only in the lockdown period with nothing else to do, sitting at home doing nothing else, I would try and search all kinds of things. That's when I came across this one. The main thing to say is that it was years ago, before cryptography became so big and all kinds of algorithms came, that such ideas have been there. Okay. So for anybody interested, you can, I've just listed 4 things. Maritime history, so whole lot of things have happened about understanding weather patterns, understanding the wind patterns, and using them to figure out if you want to sail from point A to point B, what is the best time to go, what things to avoid, what routes to take, avoid, blah, blah, blah. Okay. So his maritime history, history of astronomy, history of agriculture, history of cryptography. Very interesting stuff you will see. They are not about maths, but woven around what is described is maths also. Without maths, this is nothing. Math can be very simple. They are not using very complicated math and very complicated theorems. But ideas are mathematical ideas used to very practical things which were needed at that time. That is the part I want to stress. That lots of stuff have occurred like this. Now, medicines and vaccines. This how do they know that this medicine is going to work for such and such disease? Rare is the case. Rarest of rare will be the case where they know the entire chemical composition and how this chemical, the chemical in the medicine is going to impact the body of the patient, how will it will affect exactly the concerned part, and therefore the thing will be working. Very rare. More often than not, they have potential, they have physicists, not physicists, biologists or people working with medicines, they will have some idea, but they won't know exactly which one, and they will do trials with patients. Clinical trials, as they are called. You first start with animals, and then if it seems to work, you try with humans, and there are a lot of protocol about how to do that. But it is a combination of intuition, understanding of the domain, and data and its analysis, which maths for me is, there is no difference between maths and stats and probability and this and that, or computer science for that matter. All these are one body of idea, which is mathematical ideas, and which one will come in useful, you don't know. It's the body of all this is very much part of medicines and vaccines and so on. So now these things have to change. So there are well-written protocols. But if they had followed all those protocols in the COVID era, what would have happened? The minimum time to approve a vaccine is maybe 8 years. Now, if 8 years there was no vaccine available, we can each imagine what would have happened. We don't know what would have happened, but it would have been disaster. What level of disaster, we don't know. So, depending on the context, even the decision makers have to change their laws, they change their rules and approve of things fast. On post facto, you can debate, was it a good decision, bad decision, this and that. But decision makers have to move on. Okay, so the what to approve, what not to approve, decision has to be made. But it is a, you can say broadly speaking, a kind of a mathematical idea analysis which is at the back end of all this. Okay. Today I want to talk a lot more about telecommunications, and that's why so again, going back in time, before telephones and before any of these modern things, okay, I talked about Caesar cipher and so on, but let's not go to war and so on and so forth. But one efficient way of communication, transferring, the one thing is A shouts, stands here, shouts, B is standing there, he hears me, then he shouts, then so on and so forth. That is one way. But if the distance is too far, you will need too many people. Okay, so there's something called Morse code, and This, as a school kid, we had gone for some picnic and so on and so forth, and we have actually done the following experiment. So, Morse code means, suppose the only two things you can transmit. We can call it one as a dot, one as a dash. Okay. So, visually to transfer, this is dot and this is dash. Okay. So, 2, 1 and 2, 0, 1, dot, dash, whatever. The common thing was dot and dash, and then you have to have a space, because if you keep doing one dot and two dots have a different meaning. So a space, you can say this. Okay, all right. So now the Morse code amounts to the 26 characters are mapped to combinations. So interestingly, it is not that everything is a four characters. So based on frequency characters and what later became the basis of writing the zip algorithms, which compresses the document. So E is the most frequently occurring, so E is just a dot. Okay, so dot is I, and 3 dots is S, and so there is EISHTMO. This first line I remember, dots in combination or dashes in combination. Likewise, all 26 characters are mapped. And then one of us will stand here, let's say, I will transmit a message with E, this is T. So ET is transmitted, then I break, this means, okay, the word is finished, and so on. Okay. Somebody else could, and if I have a flag in hand, they need not see just my thing, then they can see from a longer distance. So the based on the distance available and number of people you put, you can decide how do you transmit this visual message. Okay, and then subsequently the person who receives it can transmit this, and so on. And in a summertime picnic where we were going to spend the whole night for the camp, we did this experiment. It was wonderful. So this is what is missing in math teaching, typically. Theorem proof is one thing, but when we saw at night spending time and transmitting, okay, message like this, we enjoyed it a lot. Okay, so that is about Morse code. Then came telephones, okay, where audio communication could be communicated. So there is a certain, you can call it physics, you can call it technology, engineering, whatever, where the audio thing is being transmitted at the other end. All right. Now, how would you transmit a message? All you have is audio equipment. You didn't have text to speech or speech to text converters as are available today on your systems. But all you have is a thing which will transmit audio, and you want to transmit a message. So they would do a text, written text will be transmitted to this via this Morse code, dot, and then space is just give a time gap, and that is this. So I have actually, when I went to Calcutta as a student, I had to send a telegram home saying reach safely. So I have to go to a post office, post and telegraph office, and I can see that they will be doing this tick, 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 tick. You can hear the sound. And the message is going from Calcutta to Indore, where I grew up, and then it will be decoded and printed. So there is no secrecy or anything like that. But effectively, message is being communicated. And so that's why it used to be called post and telegraph office. You could send a letter, or you could write a telegram, and the telegram will be sent to the destination, and it will be then printed there and sent home, ages ago. Okay. So over a period of time, especially with emails coming up in 90s and so on, effectively that nobody is using telegram, and by around 2000 they stopped all the equipment that they had purchased and equipped, and people who were trained to send telegrams and so on were all gone. But that is changing time, you can't fight that. But for long period it served a very, very important purpose. Okay. This is another interesting historical story. So from Europe to US, communication was an issue. The from Europe, mainland Europe to England, the gap is minimal, so there's no big loss if somebody has to actually take on a boat and go that way and come back and so on and so forth. And setting up a telephone, a line which will transmit telephone thing was also relatively easier. But the transatlantic cable was a big breakthrough somewhere around, I think, 1866, between some location in UK, probably London, but something in UK, to New York. And that was seen as a big breakthrough, because now almost instantaneous communications were possible across the channel, or not channel, across the Pacific Ocean. This revolutionized communication, and a whole lot of stuff happened around that time. Some of you, or several of you, would have read about the Enigma cipher and its breaking by the English team, and having played a role in World War II. Okay? Lesser is known about a similar role in World War I in what is called the Zimmermann telegram. Okay? So Zimmermann was the foreign minister, German foreign minister, and at a time when US was yet to enter the war, US had good German population, Italian population, also British population and other mainland Europe population. So the two groups were giving different advice to the government, whether if they should enter or not, and if enter, which side. Because right, wrong, from a distance, it is impossible to figure out. Okay? And not that they care even if they can figure out what is right or what is wrong, from then on till today. So other things decide which way if you will enter the war. All right? So, but there were warring things going on. So the Zimmermann was the German foreign minister. He came up with a plan. The plan was to threaten to ask Mexico. Now you will wonder, Mexico, how does it matter? Mexico is a tiny country where you have no power. But World War I time, that was not so. They were powerful enough. Enough to at least threaten. So they cannot be dismissed so easily. So this was a message to be sent from German foreign minister to the ambassador of Germany in Mexico City, that he should give a message to the Mexican government that they issue a certain threat that to US, that if you join that way, we will attack you. Okay? Now the problem was, the telegram has to be sent, but sending a telegram from Germany to US had to go through the transatlantic cable, which goes through London. So they will have access to they can read. Though because US had not yet entered the war, there were agreement that they are allies, they are not our allies, they are neutral, so we will not touch whatever is being sent to them. But of course, promise is promise, and what is done is different. So of course they were breaking the thing. Okay? And the next one I am going to give, this slide is going to show the picture of this so-called Zimmermann telegram. This is from the internet. And those of us who may have seen actual telegrams at home saying reach safely or this or that, they can recognize such objects. And this was typically the thing. Of course, this is Western Union. In India, it will be Post and Telegraph Office will be written there. And there will be some typed one. And over years, it would be even a better typed one, or so on. But this is how a telegram looked like. On a piece of paper, something will come printed. But now it is gibberish. It's just a collection of numbers. Okay. So it is like the Caesar ciphertext which I had shown. Okay. So this would go from Germany to UK. From UK, exactly the same copy was sent to New York or Washington, and from there it was transmitted. So that part was secret. But from there to Mexico City to go, it went over Western Union as it is. Okay. And So British people had read this, and there was a team which was trying to figure out what this gibberish amounts to. Okay. Interestingly, all written records, even the names of who are the team which broke this is not known. All that is known is team in, I think, something room 40. So the room in the British headquarters or wherever that they were sitting, that is all that is known about that in public. Maybe actually known things are known to them, but what is available is room 40. There is no, it says that the team consisted of, there is no reference to a mathematician. There is reference to linguists and what is this? Newspapers we have everyday code kind of thing. Anagram. Not anagram, the right crossword, yeah. Crossword enthusiasts and linguists. Okay. There is no reference to a mathematician. This year is 1920s. Just 20 years later, Alan Turing and all that, their names are associated and they are hailed for breaking the Enigma code. But I'll come to that story in a minute. But so there is no mathematics, only these people figuring out permutations and combinations as they do in crosswords. They could figure out what this meant. And now the problem with England was that they can't say that we have seen this and we have decoded it, because they have committed not to have seen. So the story is that they said that we got hold of this Western Union telegram which was sent in a common thing from Washington to Mexico City, and that is how they sent it to our team, and that's how they have broken the thing. There is a lot of debate about this, but some people claim that it was breaking of this which pushed US into joining the war and going with the British side. Some others say that there was anyway going to happen and this has nothing to do with it. But that apart, these are stories. But the important role that such simple things have played in our life and in societies in general, that's what I wanted to talk about. Just some years after that, Second World War happened. Now, it's interesting to think about what was it changed that in World War I, you didn't even have one mathematician in the team and they broke it. And why did you need, in 20 years, why did you need someone like Alan Turing to be part of the team? And those of you who may have seen the films about that, the huge computer equipment which is shown in which the Enigma cipher was broken, using which. So what had changed was before World War I, effectively the encryption and therefore decryption was all done by hand. Okay, so there is only so much you can do. You can't have a complicated. It's not that people could not construct a complex algorithm, but let's say I engage the three of you and give you one page to encrypt and send, and if 24 hours हाँ कर रहे हैं अभी, then you may have a wonderful algorithm, but nobody will. They'll say, "अरे पागल लोग बैठे हैं यहाँ पर," So it won't fly. So it had to be something which could be done fast, which means it puts limits on what algorithms you can use, and therefore correspond. So it's a cat and mouse game. So there is a certain give and take, and so there was only a certain kind of combinations you could do, and then once the other side is a smart group and a team, and they distribute their work, they could break. Okay. Now, in between, what had happened was that machines being used to do calculation had become a reality. It was there, but it was more commonly used. Not a computer, but machine. So, as a student, again, going back 50 years in ISI, that there used to be a machine which looked like a typewriter, which we used to do calculations. It could simply add numbers. You write a number, there were 2 registers or 3 registers, I forget. In one register, you could enter a number, and in a smart way, units digit, you do 1, then you click one button, then it moves your thing slider to the decimal 1, second place, then third place, and so on. So a large number, we all were experts. We could quickly enter a large number. And then there was a thing which you can rotate, right? Along the clockwise, it would add this number to the upper register, and this way it will subtract. Okay? So if you want to add it 10 times, we all were smart enough that we'll first move the thing with, therefore it will move it by a factor of 10 and then move it back and do 1 minus. So instead of rotating 9 times, we will do it 2 times mein ho gaya kaam. So things like that. So this was common usage, and what was accessible to the Germans were a little more complex. There are the Enigma machine. You can figure out the search. I somehow did not locate the picture I have with me, but today. So what this meant was using machines to do computations meant that now you could do lot more complicated algorithms. Okay, and since the other side only knows very roughly what algorithms you may be using, there's brute force thing would now require lot more, and some smarter team also will need lot more things to try out. And that is where the Alan Turing and his team and the computers came into the picture. So in just 20 years, it had moved from one tiny thing to a big thing to do. But now, given the way the whole the system has changed over time, not just today, just 25 years after World War, if the Enigma cipher were given to the students who were being taught computer science in the early years, they could break it. Today, you teach a little and first year students can break the Enigma cipher, given the equipment available to them, because of the huge computing power available in even our phones. But that meant now more complex algorithms and more complex coding, decoding, etc., etc. Now, going beyond war, this has a huge role. Earlier, I would have said, okay, those of you who may have used internet to do so, say bank transfer and so on, COVID ensured that it's an even playing field. Everybody was, like it or not, you had to use some way of communication and for finance, that is transactions, right? And password and login and so on and so forth. So now just imagine that how is the thing getting transmitted? What if somebody is actually catches the entire communication? You have sent a message to the bank, pay 10 rupees to me, and somebody gets that and changes that 10 to 1,000, then 1,000 will go from your account, right? So the need for what can be called secure and authenticated, and bank also later you can yourself send a message, transfer 1,000 rupees and later go and say the bank, no, I didn't say 1,000, I said 10. So bank needs to be convinced that you have sent it, and later if challenged, they have to be able to prove to others that no, it is you who have sent it. So secure authenticated communication. Without that, e-commerce would not have moved, right? And so this has become an important aspect now, the cryptography and secure communications. One other interesting mathematical construct which connected with society and even going much beyond war, at least in the Western world, people could sense it, is what can be called the error correcting codes and its use on CD, as it is called, computer disks. Okay, so error correcting code is a very simple idea, which is like, see, the all communications on radio, so remotely happening, they are subject to errors, transmission error, receiving error. Okay, even even today, landline phone you use, there can be some static, there could be some other noise coming in, less now than was before. And if while traveling from one city to the other in the car, you try to turn on and receive a radio signal, you will hear You'll say, "Ah, no, 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 this channel, there's too much noise, let's try some other song," and so on, some other channel, right? Some other radio station. So this communication is always subject to some errors. So the thing was, the error correcting code is a very simple idea. That, let's say you send a signal by whatever means, one sentence, okay? Instead of sending one sentence once, you send it 3 times, okay? And then you apply for each character by character the majority rule. If all 3 are same, anyway, no problem. If there seems to be a difference, if 2 of them are identical, you just take it is that, okay? Already, unless the error, depending on the error rates and so on and so forth, this simplistic thing which I described will correct lots of errors. Okay? That is what is the idea of error correcting code. That what you are transmitting is subject to error. You have some rough idea about the errors, and using that you can correct it. Okay? Now, so this is roughly 100 years ago, or less, 75 years ago. Let's say a song, a film song, a Western film, Indian film, doesn't matter. A song would be distributed on what was called a long playing record, or a short record or long playing record. It would be a plastic or vinyl based object, and it will be actually engraved onto that, and then a record player, you play something on it, it reads just a variation, the vibration on that disc would be decoded, and it will play the song. What this meant was that there would be, if you use it large number of times, then there will be errors coming in, and after that you will start hearing all kind of static on your device of listening. Okay, so they'll say, okay, so many times it will play fine, after that it will go bad. Then there will be competition, our record is better there, etc., etc. The using error correcting code, around that time this computer disk had come up, and they found that one disk can package huge amount of data. Okay, they could have actually done 10 hours of music, whereas one so-called long play record could do, I suppose, I don't know, I forget, some 40 minutes or 60 minutes of music. Okay, so one CD could do several hours, 10 hours of music. Now for the music company, that is a problem. That if you buy one CD, we have sold you, like, so many long playing record equivalent, then you will buy that many less CDs and my profit will go down. So they were wondering what to do, and then they came across this idea of using error correcting codes. So because, as I explained, 3-way multiplier, already you could do wonderful thing. Now you imagine you can do it 100 times multiplier and you can come out with a very perfect error correcting code. And it was advertised as, you buy our CD and you deliberately take a pen and put a scratch on it, it will still play perfect music. It was seen by people as something wonderful. Arey, ye kaise ho gaya? Right? Old records, you play little without doing anything, it is going bad. And here you are deliberately scratching it, one scratch here, one scratch there, and still it plays perfectly. This is something which people could see. Okay? Interestingly, one of the key people involved in the early important person, I'm not saying necessarily his algorithm is what was used for this production of error correcting codes for CD breaking, but one big name in that is R.C. Bose, Professor R.C. Bose, and he was a professor at North Carolina University, and along with his student called Roy Chowdhury, both Bengalis of course by the name, they corrected they created codes which are called BCH codes. Now lots of improved versions have come, but they were well-known thing. Anybody doing coding theory, this were BCH code was a part and parcel of learning what is error correcting codes. And so then the whole thing is, okay, if you can do 3 times replication, then what kind of errors you can handle? You put a bound on number of multiplier, you can, and typically 3 times is huge, even 1.2 times multiplier, already you could do wonderful things. Okay, so this is what I meant by practical people can see it. You don't have to teach them math, but you are showing them the power. You buy a CD, you scratch it and you play it, it still plays perfectly. What more practical application one can talk about, right? So, so I talked already about secure communications, which is important, but how many of you, if at all, know what these two words, telnet and SSH? SSH is secure shell, and before that there is a word telnet. So today, you come to KREA, you go to you want to access the server and connect and so on and so forth. You go to a browser and do it, okay? Now, that is a lot of overload on the data communications. Now, today there is a precise things available, so no problem. Now, let's go back not to a huge time, around the time when internet became available in India. Not for everybody, but educational institutions, even the leading educational institutions. The only exception was Tata Institute, which had early on access to things. They would dial an international call to transmit message to Europe and pay huge amounts. Others could not afford to have an international call to communicate. So early 90s, they had worked out that, and the telecom ministry or corresponding earlier entity was created in Delhi, and they came up with this thing, network thing, which is called ERNET, Education and Research Network, available only to educational institutes. We were sitting in Delhi, I was at ISI Delhi, and relatively younger fellow then, and we came to know that this is being available. So me and a friend, we go to ERNET in Delhi and ask them, what will it take? He says, what? Nothing. Right now it is experimental, there is no cost, no nothing. We'll give you a phone number, you dial into this phone number and connect. I said, but then who will explain us what to do? That we will not help you. You figure out. There is no cost, you figure out. Okay? So we come back, we read books, we read that, and so on and so forth. And so we needed what is called a modem, and we needed a Unix-like system to be able to connect through the modem to this network, etc., etc. So then we read and figured out what is a modem. So what is available to you is a telephone line, which is basically voice communication. You want to do data communication on the voice line. Okay, so the modem at both ends, it transforms digital data to audio and audio data to digital. Okay, and it is built in with error correcting codes, because we know that the audio communication has errors. And while experimenting, you can put the modem in a silent mode or play the sound mode. So initially, since we were experimenting, we would do it with the sound mode, and we could see what kind of communication behind the scene are happening, and we could even change one track and one more, all the communications that can decode and even play on the screen. So we had a lot of fun, me and my friend in ISI Delhi. We had a lot of fun reading all the communications going on between our computer in ISI and the ERNET one there. Okay, that apart, the communication speed was 1200 bits per second. Bits, not even bytes. Okay? And what that meant was that if somebody sends a long message and so on, we want shorter thing, and we don't want. So I used to be dead against using Hotmail, which had just come up, because unnecessary you are So what we were insisting was that you have to use the text mode, which is secure, which is a shell mode or whatever it is called today, terminal. So you say mail and then write the address. Enter, then it goes to the next line, there you write a message and then enter, it sends. Okay. To communicate, so to connect to the institute server, you had to do telnet. So you say telnet and the address for your server, and then it will connect and so on and so forth. Now, by design, telnet was a way of protocol which was, there was no security built in. Just like in internet communication, no security is built in. If at all you want, you have to do HTTPS, where the S layer is added, secure layer is added. So telnet was happily without any security. And in even 94, 95, we heard stories that one of the IITs, I won't even name which one, the faculty was very happy that now you don't have to walk to the office and hand over the question paper for the next exam. You can send by email to the office, and the office will print and send it to wherever it is to be done. And faculty was very happy that sitting in office they can do telnet, office address, and send a question paper. Students figured that out. Okay. And the design of telnet was such that anybody in the local area network, so the codes, the numbers, you would have seen 4 something dot something dot something dot something, numbers between 0 to 255. Okay, so the 4th one is the local thing. Okay, so A dot B dot C dot D. So anybody who has A dot B dot C dot address could actually read everything going on between any 2 computers between A dot B dot C dot D. All you had to do was run one particular executable downloadable from the internet and give the address between these 2 machines you can get. Including login. When you type the password on your system, it will put, when you password thing, it will say star dot star dot star star stars. The other one who is logging, searching you, he can see the password you have typed. That is what telnet was. So then we learned, okay, let it happen in IIT, but we don't want it to happen here. So we wanted to insist that in ISI Delhi we will disable telnet and have SSH only. Various colleagues started shouting at us that what is this? We are happy to use this system. All your imagination and thinking that it will be broken, this and that. So we go to our head's office. He was an economist at that time, very little to do with computing, but he trusted us. So we told him that, look, this is not good. We should issue an order that you are disabling telnet and get SSH. So he trusted us, but he said everybody is up in arms. So, it will be so much unhappiness. Can it not wait? Is it that critical? So we said, okay, let's do an experiment. So we told the head that call the system administrator. We ensured the system administrator was not in the computer center, but gone to his office. So we said, call him. He called the system administrator and tells that, oh, something happened, my password is gone. I want you to reset my password right away. I am on an important meeting. So faithfully, boss ne bol diya hai, so without some computer center was 2-minute walk. He has to just come out, walk a little and go. But instantly from his office, he logs to the server using telnet. And we were already know from what address to what address he is going to do. So, and we wanted to do it in presence of the head, that he has to see what is happening. So on his machine, this was running. And he sees our computer administrator logging in, and he could get the system password by which the entire thing is open. He immediately calls him and says, drop that and disable telnet. So this is because if we use a system which is built for some purpose and you use it for a bigger purpose, you don't know what can happen. And that is how we have the HTTP protocol was meant for like telnet. And now the HTTPS has been done because of this misuse possible. And now it is, what happens in the back end is very interesting. Now it will take long to describe. You have other colleagues who can tell you what happens. What is the difference between using HTTP and HTTPS? The communications between your system and the other end system, lot of things that go on behind the scene. Okay? So the point is that so many things which we do daily in our lives, behind the scene there is a whole lot of math happening. We are blissfully unaware, you don't have to be aware. But as long as we know that there is a whole lot of math behind the scene, and the math people know, at least if challenged, I should tell you what happens behind. It's not good that I have read somewhere ki ho sakta hai, what is, kya ho sakta hai. I can explain, right? So, if we can communicate this to students in math teaching, at every level, the interest in math will grow. Pure abstract math, okay, some of us like me or some of the colleagues here took interest in that and went and studied math, and teaching math is yes. But then there are lot of others who got turned away from such ultra abstract thinking with no connect with real world. I think we all will agree that if there is more connect with real world, more students may take up to also understand math. Not necessarily take it as their career, but at least understand a little, not turn away from math. So that is the message that I want to give to everybody, that there is a whole lot of math going beyond theorem proof. I'll quickly some more of my own personal experiences and I will complete. So firstly, the multiple choice questions and tic-tac-toe exam, as I call it them, they are here for us to stay, whether we like it or not. A large number of students appearing and lakhs of students across the country, and any other form of doing an exam has its own limitations. And that alone gives a whole lot of issues. How many questions should be there? People argue, how does it matter? Whatever is the rule, sabke liye same rule hai. But you think a little bit and it matters, because to avoid copying, what is done is the order of questions is permuted in many exams. Two people sitting next to each other, you may have the same exam, same questions, but they may appear in different orders, so that just quick looking at the other doesn't help you read the answer, because you can't read the question that long, etc. But that already means if large number of questions are there and they are arbitrarily permuted, then the candidate for whom the easier questions come first has an advantage as compared to someone else who has a different order, right? So what somebody dismisses at sabke liye same rule, how does it matter? They have to understand that no, it matters. Then there are this, if the number is several lakhs, you can't have that many computer systems, so you do several versions of this. GRE, TOEFL or other things abroad, Western world, what they do is you have a question bank and you randomly select some questions, and for each question based on the history, you have their difficulty levels and you try and match difficulty levels. It has its own challenges, but in India that is not accepted. They say question once exposed you should not be using again. You have to at least rephrase it, redo it anyway. But that means that it is left to the expert group to figure out that these two are equally difficult questions, question papers. And being participated in tons of such question creation with to the best of our effort also, we can see that what appears to be equally difficult for us may turn out to be quite opposite for students. There is a huge difference. We can figure out that the thing is. So that leads to something called normalization, that you answer the scores in two different papers, how do you compare the two? And that leads to a lot of mathematics, and not correctly done, it leads to all kinds of stuff, court cases, and so on and so forth. And me and some of my colleagues have been involved in court cases and so on and so forth. So these are simple but very important, because you need to be fair to the students. At the same time, you have to be fair to the entity which is creating the exam, right? Because you want the best students. You don't prefer A versus B, but if A is better than B for your purpose, you want A and not B, right? So whole lot of such issues come up, and then there was one case where actually I was still in ISI Delhi, and one day a CBI inspector turns up to my office. Okay, and this was the year was something like 2004 or 5, and there was a story in the newspaper. The Delhi College of Engineering, there was huge cheating, thought that there is cheating because large number of students selected have identical marks in physics, chemistry and maths. Okay. So that was a story. I had read in the newspaper in the morning, then I am sitting in my office, the CBI inspector comes and asks me, have you read this story? I said, yeah. So he says, what do you think about it? I said, what do you mean, what do I think? He says, no, my question is it statistical evidence that they have cheated? I said, I can't answer it like this. At best, it is surprising. But I said, after all, there are 60 math questions, 60 physics, 60 chemistry. Okay. Now, to be able to be selected, If you're not having 55 and maybe physics and math and chemistry a little less maybe, but unless you are near the top, there is no chance of you being selected. So the total number of lakhs of students have written. So total number of slots available is not that many. So identical, all three identical, okay, surprising, but there is no proof of evidence. There is no evidence that there is a. So he says, oh, I thought you may have an answer. Then I said, okay, if you give us the, by then things had moved that the answers and everything will be recorded on the Excel sheet. So you have question-wise, candidate-wise, candidates are rows, 180 questions are columns, and A, B, C, D, O. O is omission and A, B, C, D is the fourth choices, standard thing. I said, you give me the Excel sheet of all the 1 lakh students and I can quickly say whether this is evidence of, what model I will use, I will come later, but yeah. He said, no, we can't do that. That's privacy. I said, then we can't answer your question, too bad. Next day he comes, says, I cannot give all the candidates, but these 27 candidates in question I have. He had a USB drive. By then you didn't have to have floppies, but USB stick. Here are the things for these 27 lines for these questions. I plug it in and I stare at it, and I know that there is evidence of cheating. How to write is a different matter, because not only their totals were identical, all their answers were identical, including omissions. They have omitted the same. When they are right, they have the same. When they are wrong, they are the same. Now you need to have a model of how do you. Now it's clear. Let's say this is admission to engineering, and you put some class 5 level math question, okay, and you say that, oh, these 40 candidates have identical answers. They have cheated. Will it make sense? I mean, if you put a very easy question, then obviously they will have, hopefully they are, those who are at the top will have answered it correctly. So the correct answer matching doesn't give you any evidence. Wrong answer matching may give you some evidence. Then you have to get back into the question and simple, but you can, the deeper you get, you can do analysis, and then you can say that this is questionable, this is not questionable, and so on and so forth, right? So what I am trying to say is very simple, and you don't have to be probability theorist or learn this theorem, that theorem. Common sense and open mind, and you can do simple compute things like this and figure out whether this is cheating or not cheating. Such things go to courts and go up to Supreme Court, and Supreme Court appoints committees. Of course, unfortunately, the reports written in a Supreme Court committee sit there, and implementers don't do anything about it. So I have been on committees appointed by Supreme Court on these MCQ exams and the mishaps happening around that. We have written, including Nandan Nilekani and similar people, we have sitting on core reports and written, but unfortunately we see the same thing continuing. So what happens to the thing is a different matter, but these are simple questions which have huge implications. Okay. Okay. Let me just come to the last one. Electronic voting machines and VVPAT. Okay. Voter verifiable paper audit trail. So with all kinds of things in 2019, when the whole lot of cases in the Supreme Court, the Election Commission appointed a 3-member committee which included me. Not as Chairman National Statistics Commission, I was not even a member then, but through some other reason. And the thing was that they had a protocol that in each assembly segment they will choose one booth at random, and then they will do the physical count of VVPAT count and match and see that it matches with the EVM count, yes or no. And their question was that our protocol means that they are going to randomly select what amounted to be like 4,025 booths across the country, and if they all match, can it be taken as statistical evidence that the EVM design is good? And there is a mismatch, if any, is minimal. It could be accidental, and there is no way of planning it, etc. And we did write a report. It is there, and that report was the basis on which the Supreme Court ruled a very important court case in the Supreme Court just before the 2019 election. So The math and probability is just what we may teach in the first year course in statistics probability, binomial distributions and the simplest of testing of hypothesis. Okay, but very simple math, but has a huge impact of this kind of a level. Okay, and it is this which gives me a lot more pleasure than writing a more complex theorem. Having proven, I may get more acknowledgements for that, but personally I am much more satisfied when I can do something which may be very simple but is a huge impact. Because imagine in 2019, if the Supreme Court had turned and said, you know, the EVMs are not good, there would have been chaos across the country, because last minute they can't change the protocol from EVM to printing ballot papers and distributing and the ballot boxes. And the elections would have to be delayed. It would have been a real destabilizing effort. But as a mathematical expert, without taking into account what will be the impact, it is not that the impact will be used, so no, better write a report to say everything is okay. That could be one approach, but no. Maybe if our report said this is not good enough, what they would have done, I don't know. They could have formed another committee to write that report they wanted. It is up to them. Okay, I don't say therefore that what would have happened, but it could have happened, is what I mean. But the thing is very simple, probabilistic, statistical, mathematical ideas, correctly applied and with reason, can have a huge impact in society. So let me stop.
No, I just also was just curious if you could talk a bit about your work on sampling for voting elections in Indian society. I mean, because I heard a lot from my professor K. Ghosh, who told me all this to talk to you if I was interested.
Okay. So, yeah. You mean opinion polling?
Opinion polling.
Not the EVM business, but the opinion polling. Yeah. So okay, so in any such statistical exercise like opinion polling, which I did for like 20 years, Lok Sabha, Vidhan Sabha, various states, Vidhan Sabha, etc. So one has to start with is what is your objective, okay? If the objective is to predict winner at each constituency, then you have to do differently. If your objective is to say that if any party or alliance is going to get the majority or not, if yes, by how much, if not, short by what, which will be the largest. So if you want to do kind of a prediction on the overall basis, then something different needs to be done and much smaller sample size may be sufficient. So starting point has to be there. You know, people have argued with me, if you can't predict who is going to win here, how will we figure out that you will do something at the national level? So it is cancellation of errors, okay? As long as you are not motivated, it doesn't go wrong even if individual thinks you are way off the mark, but totally you can come out to be correct. So it has to start that way. What is the objective? And then what are the resources available? Okay. Now you have a choice of saying that no, it cannot be done, we can't do it. Or you say it can be done, but the answer is very maybe iffy, and you can reveal that in when you disclose your hand and tell what is the thing. Okay. So there are many questions such as, is the past data important or not important? If yes, is it all data that you can get hold of all election data in the history, not individual voting, but constituency wise voting data you can get across time. Which one should be used? Okay. And that is where, apart from data and the analysis, the domain knowledge and what the domain experts feel becomes very important. So, for example, on television you can hear them going on and on about caste and religion and subcaste and gender. What role each of these plays in election analysis, and does it not play or does it play? Okay, even if you grant it plays, what data do you have about them? Past data, do you know which way men voted, which way women voted, which way rich people voted, which way poor people voted? You don't know. All you have is constituency-wise total. Okay. When you want to choose a sample, you can do two things. You can either look at people and figure out they are rich or poor. Men or women you can figure out in most cases at least. Then age you can guess maybe. But it's all iffy. Okay. And then you are only sampling amongst people who are traveling around. What about those who have not left home? You are missing them out. So the caste and this kind of other socio-economic variables, you can't use them to choose your sample. So you have to figure out what is feasible, what is not feasible to do. As I said, you always have a choice of saying, no, it cannot be done, or try the best what you can. So one has to start with that. And surprisingly, we found that nationwide, the first time I did that, 1998, target sample size was 15,000 plus and achieved sample size of just under 10,000. Properly selected randomly with a proper protocol was good enough to tell us what is likely to happen in the nationwide election. Things like, questions like the media or media house, TV station which is doing it, they'll say, for nationwide you did sample, so much sample size, your cost was so much. Next election is a state election for Tamil Nadu. Tamil Nadu is 6% of the country, so now we'll give you 6% money of what we give you nationwide. We tell them, no. The sample size is important, not sampling proportion. They think we are playing a fast one on them, cheating them. So very interesting experiences, but we need a full hour just to talk about the actual experiences on election stuff.
So here I had a question. So we hear of this Gallup, there are all these polls in the US.
Gallup.
And other things.
Yeah.
I mean, they poll, every day there is some poll on something. So are those very different from what in the Indian context?
Firstly, there is no Indian context, okay? Each agency does their own way, okay? And the worst part is they don't even have to disclose what they have done. Like, I am known to have done this election for 2 decades. I am known in this domain for all channels. Everybody there knows me. Now, nothing prevents a new channel to put me up on air and I go and tell them, I can cook up numbers. So many people we sampled on such and such time, and this is what their opinion is. I have no data. I can go and brag and nobody can challenge me. I don't have to show them anything. Nobody. I'm not answerable to anybody. And that is done, not by everybody, but some people do it. So, but properly done poll in India and what is done in US, what they declare, are very different. Typically, they are only telephone polls, US. Door to door, they are saying, are we crazy? Who will go door to door to ask questions? But any other method, there is reliability is highly doubtful. Even there, they are aware that because now with phone surveys, landline phone lena hai, mobile lena hai, already question mark. Mobile, you don't even know from which location they are living. Because now it is portability. You started in Delhi, we moved here, now the same phone is continuing. I can move away from Chennai, go somewhere else, the same number can continue. So using phone number, it is even impossible to figure out which city you are going to vote for, which city you have a valid vote, etc., etc. So there is a whole lot of questions on telephone polls. So I declare myself to be an expert on Indian polling. I don't even claim anything globally because every place there are different nuances.
Are there other questions? Anything appearing online? With a question? Okay, in that case, let's thank Mr. Karandikar again.
So, this is from KREA side as a token of appreciation. Thanks a lot.
Thanks a lot. Thanks a lot. It's a pleasure to talk to a live audience who is interactive. interactive not just by speaking, but by looking at faces, I can figure out who is interacting and who has closed their eyes and are thinking of something else. So that's what I meant by interactive. Thank you.